derivative rules. So it's kind of the second half of these notes. So derivative rules are shortcuts to that limit definition of the derivative we did in our last notes. Okay, so LDD, big long mess, takes a long time, kind of tedious, especially if we start getting into more difficult and more complicated functions. So mathematicians started to come up with a couple of kind of rules or shortcuts as they started to notice patterns emerge. Okay, so our first one is the constant rule. So if I'm taking the derivative, remember that d dx means to take the derivative of some constant c, then my derivative is just 0. Okay, because you think about it, if I have a function that's equal to a constant number, that function would just be a nice straight line. And what would the slope be along that straight line? Well, the slope along that straight line would be 0. So a function that would represent the slope of a constant at every point would have to be 0. Okay, so let's find our derivative. So we have y is equal to 7. Well, then that would mean y prime is equal to 0. F of x is equal to 0. Then f prime of x is equal to 0. Derivative of 0, which is still a constant, just 0. S of t equals -3. S prime of t is equal to 0. Y is equal to pi squared. Y prime is equal to 0. Now you're like, Mr. Boom, pi squared, but that's like a variable or something. Well, remember, pi is a number, 3.14, and then all those numbers that come after it. So it's still just a constant. So even though it's pi squared, just did that to try and confuse you, still just 0. Okay, the next two rules we're going to look at are probably going to be your most used rule by far. Okay, and it is the power rule. So the power rule is for if I have x to an n, so some integer, some power n. Okay, so if I'm taking the derivative of an exponent, then I move the exponent to the front to be multiplied, and then I subtract 1 from the exponent up in x. Okay, so I move the power down, and then I subtract the power by 1 for what's still up in x. Okay, now the derivative of x, I want you to think about, well, what's the power on x? Well, the power of x is x to the first. So if I move that power down by 1, that would be 1 times x to the 1 minus 1. Okay, so 1 minus 1 is 0. What is x to the 0 power going to be? Well, x to the 0 power, as anything to the 0 power is just 1. Okay, so the derivative of x is just 1. The x goes away because it becomes x to the 0, which just is equal to 1. Okay, let's actually look at some examples. So I want to find the derivative of f of x is equal to x cubed. So that gives me f prime of x is equal to 3 moves down, x to the 3 minus 1. So I'm subtracting 1 from the power. So this gives me 3x squared. Okay, so notice from my original answer to my end result, my power went down by 1, and the power that was up here moved to be in front of the function. Okay, and it should match up with, if you remember over from our LDD, when we were finding equations, like in this case, our equation was 2x squared minus 3. Okay, the 2 moved down to become 4, and x squared became just x for 4x for our derivative. Up here, where we had x squared plus 2x, x squared became 2x, 2x became just 2. Okay, so those same derivative rules that we're talking about in these notes come from that LDD. So a bunch of mathematicians went and did the limit definition of the derivative so many times that, like, you know what, we could come up with a general rule to make these a little bit easier. So you get to do the easy stuff instead of having to do the hard stuff all the time. So we have g of x is equal to x to the 5th. So g prime of x is equal to 5x to the 4th. Move the 5 down, subtract 1 from the power. Okay, now 10 and 11 are a little bit different. Both of these still involve exponents, but there's something we need to do first before we can deal with those exponents. So here with g of x, we have the cubed root of x. So if you remember, any square root can be written as a fractional power. So this is the same thing as x to the 1/3. Now, when I move that power down, so this becomes g prime of x is equal to 1/3 x. So I still move the 1/3 down, okay? But now it's 1/3 minus 1. I'm going to go ahead and make it easier on y'all and change that minus 1 to be minus 3/3, which 3/3 is the same as 1, but now I have a common denominator, so I can actually subtract. So to simplify this out, g prime of x is equal to 1/3 x to the negative 2/3. Hey, now you can move that x to the negative 2/3 back down to the bottom of the fraction, so you can absolutely change that to be 1/3 x to the 2/3, like so. Okay, you can absolutely make that change, but you don't have to. You can leave a negative exponent in your answer as long as it's in an equation. Okay, in calculus, we're going to get to be just a little bit lazier sometimes with our final answers because you are on a time-sensitive test. So it's not necessarily in your best interest to fully break down and simplify everything. Okay, let's look at 11. So 11, we have 1/x². Okay, so we do have a nice pretty power, but right now our power is stuck in the bottom of a fraction. So unfortunately, we can't apply our power rule if the power we're trying to take is in a fraction, because it's kind of like it's a function within a function. We're trying to apply the power rule to a function that's inside a quotient, which is another type of function. So I got to get rid of that fraction. So to do that, I can take my x² and I can move it up to the top. Now, when I do that, that's going to change this to be y equals x to the negative 2. Remember, that is my negative exponent property. So moving a base between the top and the bottom of the fraction is going to change it between a positive and a negative exponent. Okay, so now that I have that y equals x to the negative 2, I can bring that negative 2 down. So this becomes y prime is equal to negative 2x. Now, negative 2 minus 1. So minus 1 is just going to get more negative. So it's actually going to be a larger number, but further down in the negative direction. So this becomes y prime is equal to negative 2x to the negative 3rd. Okay, and then once again, just like on 10, I can leave that answer, but if you would like to, you can change this back to a positive exponent. So you don't have to change back to a positive exponent, but you can if you would like to. Okay, so that is our power rule. Okay. Let's do a little bit more application. So 12 and 13, we're going to find the slope of our graph, and then we're going to find a tangent line. So on 12, we're going to find the slope of the graph of f of x is equal to x to the 4th when x equals negative 1, x equals 0, and x equals 1. Well, to find the slope, we need the equation that gives us the slope. The equation of slope is our derivative. So I need to find my derivative. So first off, we find, not squares. So first off, we find f prime of x, which would be 4x cubed. Okay. Then to find my slope at all these x values, I'm just going to plug these x values in. So f of negative 1 is equal to 4 times negative 1 cubed, which would be equal to negative 4. F of 0 would be equal to 4 times 0 cubed, which would just be equal to 0. And f of 1 would be equal to 4 times 1 cubed, which is equal to positive 4. So those are my slopes at all those various values. So see how my function of the derivative gives me the slope of f of x at any point. So I just plug a point into my derivative equation to get the slope of the original function. So 13, we want to find the equation of the tangent line f of x equals x squared when x is equal to negative 2. Okay, so as a reminder from our LGD notes, we're going to use that point slope equation. So y minus y1 is equal to m x minus x1. So I need m, I need my slope, and I need x1 and y1. I need my x value and my y value. So first off, I can go ahead and find my derivative to find my slope. So f prime of x is equal to 2x So f prime of negative 2 is equal to 2 times negative 2, which is equal to negative 4. So I have slope, I have x1. The only thing I don't have is I don't have y1. So I'm also going to plug my negative 2 into my original function. So f of negative 2, which would be negative 2 squared, which equals 4. So right here I have m, I have x1, and I have y1. So I can plug all these things into my equation to get my tangent line equation. So y minus 4 is equal to negative 4 x plus 2. And that would be my tangent line equation. Okay. The next rule we have is the constant multiple rule. And y'all, as always, feel free to pause this as you're going if you're getting a little lost or confused or you want to go back. Okay, so the constant multiple rule is the derivative if I have a constant being multiplied by some function x. Okay, so the constant multiple rule, as opposed to over here where a constant by itself is equal to 0, if I have a constant being multiplied by a function, I'm going to completely ignore that constant and just take the derivative of my function f of x. Okay, so constants by themselves become 0. Constants being multiplied to another function are ignored and stay exactly the same. Okay, so let's look at this a little bit in practice. So on 14, we get y is equal to x to the negative first. I move that up because I can't apply my power rule when it's in the bottom. So now when I take my derivative, y prime is equal to 2 is going to stay the same. I'm not going to do anything to mess with 2. Now I'm going to drive my function, negative 1 x to the negative 2. Okay, and then I can just simplify a little bit. You can actually leave it like this, totally like this if you want to, but you can also multiply it out. So y prime is equal to negative 2 x to the negative 2, or negative 2 over x squared. Okay, all of those three would be acceptable answers. As soon as you've taken your derivative, you can leave your answer exactly as it is. You don't have to simplify from there. Okay, I'm going to do one more to help y'all out. Okay, so let's look at 18. 18, we have y is equal to 5 over 2x cubed. Okay, now it would be super nice if I could move that in to the top, but unfortunately I can't do that yet. I have to evaluate that cubed first, okay, because then I'm going to end up having to take 2 and x to the negative third power, and that's going to be a little bit of a mess. So before I move this, this is going to become y is equal to 5 over 2 cubed would be 8, and then x cubed is x cubed. So now I can change this to be y is equal to 5/8 x to the negative third. And now I can apply my derivative. So y prime is equal to 5/8 negative 3x to the negative fourth. Okay, and just like I said, you can leave that there, or you can go ahead and simplify it out. So y prime is equal to negative 15 over 8 x to the negative fourth, or y prime is equal to negative 15 over 8x to the fourth. Okay, I'm going to let you all try and do the rest of them. I'm going to pause the video real quick, and then you can check your answers at the end. All right, y'all, so over here for 15, we have 4t squared over 5, so that 2 comes down. We get 8/5 t, okay? 2 goes down to 1. Over here on 16, okay, this is probably the hardest one that I left for you to do on your own. Okay, we have 1 over 2 root 3 of x squared. So we can change that root 3x squared into x to the 2/3. The 2 stays on top. The 1/3 of the cubed root goes to the bottom. So we have 1 over 2x to the 2/3. Then I can move that x to the 2/3 up to the top, and we get 1/2 x to the negative 2/3. Then that negative 2/3 moves down. Negative 2/3 minus 1 is negative 5/3. So I can leave it like this, or I can simplify it into negative 1/3 x to the negative 5/3, or simplify it further into negative 1 over 3x to the 5/3. Either is fine. Okay. On 17, we have negative 3x over 2, which is just the same as negative 3/2 x. So negative 3/2 stays the same. X goes from being x to 1. So we are left with just negative 3/2. And then last but not least, 19, y equals 7 over 3x to the negative 2. Move that x to the negative 2 up. So we get y equals 7/3 x squared. Okay, which means y prime is equal to 14. That 2 multiplied with the 7 becomes 14 over 3. And then x squared goes down to x. Hey, two last rules to look at. We have the sum and difference rule. So the sum and difference rule says that if I'm taking the derivative of two functions, f of x and gx, being added and subtracted, okay, then all I do is I derive each of those functions and keep the addition or subtraction the same, unless, of course, the derivative changes that. So looking at 20, we have f of x is equal to x cubed minus 4x plus 5. So f prime of x, I derive each piece separately. So 3x squared, negative stays the same. 4x becomes 4. Positive stays the same. But what does positive 5 become? Positive 5 becomes just 0. So my final answer would be f prime of x equals 3x squared minus 4. 21, g of x. Okay, g prime of x equals negative x to the 4th over 2. That's just the same as negative 1/2. So this becomes negative 4/2 x cubed plus 9 stays the same. 3x cubed becomes 9x squared. Subtraction sign stays the same. 2x becomes just 2. And once again, I can leave it like that if I want to, or I can just simplify that out into negative 2x cubed plus 9x squared minus 2. Okay, so sum and difference, pretty straightforward. You just ignore addition and subtraction. Keep it the same. All right, the last two that we're going to talk about is the derivatives of sine and cosine functions. Okay, so there's a longer explanation for why their derivatives are what they are, but I'm going to kind of shorten on that to keep these notes shorter. Ask me in class if you would like to know. Okay, so the derivative of sine of x is equal to cosine of x. The derivative of cosine of x is equal to negative sine of x. Okay, now the cool thing that ends up happening because of this is, well, then if I took the derivative of negative sine of x, it would equal negative cosine of x. And then if I took the derivative of negative cosine of x, it would equal positive sine of x. So we actually end up kind of creating this circle effect where the derivatives of each of these functions go around in a circle like such. Okay, so derivative of sine of x is cosine, derivative of cosine is negative sine, derivative of negative sine is negative cosine, derivative of negative cosine is sine. So just like that, they kind of go around in a circle a bit. Okay, so let's find the derivative of 22. Y equals 2 sine of x. Okay, well, just like we talked about before, 2 is a constant being multiplied, so it's going to stay the same. So y prime is equal to 2. Sine of x's derivative is cosine of x. So this just becomes 2 cosine of x. Nice and easy. 23, we have y is equal to sine of x over 2. Okay, sine of x is cosine of x. Okay, divide by 2 is just the same as multiplying by 1/2. So to make this a little easier to see, this is the same as y equals 1/2 sine of x. So that means y prime equals 1/2. This becomes negative cosine of x, which I can leave it like that, but that looks kind of weird because it almost looks like 1/2 minus cosine of x. So we can change it to be negative 1/2 cosine of x. Okay, hopefully makes sense. Last but not least, 24, we have y is equal to x plus cosine of x. So remember, we treat each of these derivatives separately. So y prime is equal to 1. Plus sign stays the same. Cosine of x becomes negative sine of x. Oh, I'm crazy. Did I just make that negative cosine over there? Ignore Mr. Arbone and his crazy person ravings. The derivative of sine of x is still positive cosine of x, like I told you not 4 seconds earlier. So 23 is cosine x. Sometimes I do stupid things. Okay, on 24, cosine of x becomes negative sine of x. Okay, so we have 1 plus negative sine of x. So that plus minus is just minus. So 1 minus sine of x would be my final answer. All right, y'all, and those are your basic derivative rules. We're going to kind of apply these more and more over the next couple of days. But today in class, we're just going to be practicing using all of them, all right?